11.5 is what we're covering today. It's the last section of the unit. And it's actually, like I said, our last set of notes, period. Okay, you can see the next 3 weeks, the last 3 weeks of school here. We've got our notes today to finish out Unit 11. You're going to have a work day tomorrow to finish up any assignments from Unit 11. And then you'll get your review on Wednesday, be able to work it, ask any questions Thursday, get any clarification you need, finish it up. And then the review will be due Friday, and that's when we take our test. And that's our last test. That's our last grade. So our last set of notes is today, and our last grade that's going to go in the grade book is Friday. Then next week, we'll have a couple of days where you can just do test corrections or retakes if needed. I should also add to this any makeup work. So if you have any incompletes from any daily grades or the reading writing grade, anything that you still could possibly do to get your grade up, you can do this on these 2 days. Okay, that's going to be the last chance to turn in or class time, I should say, to work on and complete any of that missing work and to do test corrections, test makeups, test retakes. And then on Wednesday, the 14th, you'll get your semester exam review. If it's likely that you will be exempt, then you don't have to do the semester review. Okay, the semester review itself is not a grade, but if you are taking the semester exam, you will want to do the review because 1, it will prep you for the exam, and 2, you'll get to use that review on the exam. Okay, so those of you who are going to take the exam will want to complete the review so you have it to help you on the test. And then your test is going to be Tuesday the 20th. That's 5th and 6th period. Those are both my CPM classes. So whether you're in my 5th or 6th, we're testing on that Tuesday the 20th. I will not see y'all, or actually I will see y'all on Monday. You'll have your 2nd period exam, and then you'll have a review session for 5th and 6th period. So I will see you. It's just an extra day to work on your review. Okay, so and then that Friday, if you're doing the senior walks at like the intermediates and elementaries, you won't be in class. You'll be doing that. But yeah, so there is not much left. Really, it's just this week, and after this week, it's just makeup work and prepping for the review if you're not exempt. Okay, and then your senior clearances stuff is due here. Got graduation practice, and then summer starts, and graduation is that Friday night. So that is it for my seniors. You're moving on. Okay, so let's take a look at 11.5. This is the last set of notes for the year. Okay, so when we are looking at this, I want to move this over here. Not what I want. I want the blank one. Here we go. We've been talking about probability. I know you all had the weekend, so you may have forgotten some stuff. I'll kind of refresh your memory on probability as we go. But tomorrow. So Venn diagrams are just another visual tool. It's another way to represent some data. We've talked about box plots. We've talked about histograms. We've talked about probability, central tendency, like mean, median, and mode. Okay, so last but not least, we're going to talk about Venn diagrams and answer some probability questions using the Venn diagrams. So you may have seen Venn diagrams before. Most of you probably have. They're not just used in math. You could have seen them in any of your other courses, actually. They're just a way to visually represent similarities and differences in concepts. Okay. The box around the outside of the circles, the overlapping circles or ovals, okay, this represents the universal set. Okay, so that's just a term you may want to underline or highlight. So the universal set is everything in that thing. So the universal set is just everything in that rectangle. Okay, so some things are going to fall inside the circles or ovals, some are going to fall in the overlapping portion, and some will be outside the ovals but inside the rectangle. Okay, that means they don't fall into these groups, but they are part of the universal set. Okay, and then of course the other sets, or you might call them subsets or subcategories, are represented by these circles. Okay, all right, and then the overlap is what the subsets have in common. Let's just jump into an example. I think you'll kind of get the hang of it and kind of refresh your memory on how to use a Venn diagram. So we've got a set of data, okay? This is our universal set. All of these numbers are going to go into this rectangle. Now, there are subsets A and B. Okay, so subset A is multiples of 3. So I'm going to put subset A here on the left, and I'm going to write multiples of 3. That is subset A. Okay, so any of these numbers that is a multiple of 3, meaning I could count by 3s and I would get to that number, or I could divide that number by 3 and get an integer. It divides evenly by 3, is going to fall into this oval on the left. Okay, and then subset B are numbers that are multiples of 5. Okay, multiples of 5 are, if you were to count by 5s, numbers you would hit, like 5, 10, 15, 20, 25, 30, etc. So let me again remind you that the middle portion is the overlap. Okay, it's numbers that have these subsets in common. Are any of these numbers from 10 to 25? It's just the list of integers from 10 to 25. Are any of them multiples of 3 and 5? Any of these numbers divide by 3 and by 5 evenly? What do y'all think? 15. Okay, so if I go to list, my multiples of 5 are probably going to be the easiest ones to list. Okay, I would start with 5. 5's not in our universal set because this starts at 10, but 10. And then 15 is also a multiple of 3. So I'm going to list it in the middle. Okay, and I'll mark that off my list. Okay, and then I marked the 10 off because I wrote the 10 already. So 10, 15, 20. And 25. Those are all my multiples of 5. 10, 15, 20, 25. Does everybody agree with that? Okay, now I'm going to list my multiples of 3. I'm going to do these in red in this oval on the left. Okay, so if I count by 3s, 3, 6, 9, none of those are in the subset, and then 12, and just keep counting by 3. 15 is already listed in the middle. 18, 21, 24, and that would be it, right? I just kept counting by 3s to get my multiples of 3. Now, all the numbers that are left here that I did not use yet, it's because they're not a multiple of 3 or 5, are they? None of those can be divided evenly by 3 or 5. So those would be out here in the rectangle, but not the ovals. So that would be 11, 13, 14, 16, 17, 19, 22, and 23. Okay, so now to answer probability questions about this data, I need to know the total. How many numbers are listed here? So you could count how many numbers are listed there. Okay, there's 10, 11, 12, 13, 14, 15, 16. 16 total numbers. Okay, so I'm just going to list that up here. So the total is 16. The first question asks about the probability you randomly select a multiple of 3. Well, how many of my 16 numbers in this universal set are multiples of 3? So how many were in this oval on the left? There's 1, 2, 3, 4, 5, including the 15, because it's part of the multiples of 3. So there are 5 multiples of 3 that I could pick out of a total of 16. So my probability is 5 in 16, because remember, probability, if you need a reminder, is your favorable outcome. How many possible favorable outcomes are there over the total possible outcomes? So in this case, 5 out of 16. If you can reduce, you reduce your fraction. That one does not reduce. Okay, now this is just a notation for probability. The capital P is probability, and what's in parentheses is the probability or the events you're looking for the probability of. So they want to know the probability of A and B. Okay, so A, that was multiple of 3, and B, that was multiple of 5. The only one that falls under both, okay, and is that middle section here where they overlap. So how many numbers are in this overlap? There's only one number listed there, isn't it? 15. So there is only a 1 in 16 chance that I would select a number that is both a multiple of 3 and 5. Number 3 says, what is the probability of choosing a multiple of 3 given it is a multiple of 5? Okay, so that phrase right there, given it is a multiple of 5, is telling us we're only picking from the multiples of 5. So we're only picking from subset B. So subset B here, there's 1, 2, 3, 4. So there's 4 numbers that fall into this category. That's the only ones we're going to pick from. Okay, so that's my new total for this problem. There's only 4 that I'm picking from. What's the probability that I would pick a multiple of 3? Well, of that subset, only number 15, only one of them is a multiple of 3. So there is a 1 in 4 chance for this. Now I want to rewrite this in the notation that you see above in number 2. The way that this is written, you would say the probability of, you'd have your P and then a parenthesis. To show that you want to have a given stipulation, you would say, so the probability of a multiple of 3, well, multiple of 3 is A, subset A. So the probability of A, and then how you write that given that you're picking from subset B is a slash or a vertical line here. So given that they are a multiple of 5. So what's the probability of picking a number from subset A given that it is also subset B? So 15 is the only one, and then you're only picking from these. So it's a 1 in 4 chance. Now this one's reversed, number 5 over here. I'm going to skip 4 for now. What's the probability of choosing a multiple of 5 given it's a multiple of 3? So this one just reverses it. So the given part is multiple of 3, which is A. So they're saying B given A. So now there's still only one number that falls under both, but this time the total 1, 2, 3, 4, 5. There's 5 numbers that I could pick from, and only one of them would fit the criteria. So there's a 1 in 4 chance for A given B. There's a 1 in 5 chance for B given A. All right, and number 4 here says the probability that the number you pick is not A and not B. So we don't want it in either of these ovals or circles. So that would be these yellow numbers down here. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 that you could pick from, or 8 that you could select that would not fall in A or B out of the total number of 16. If you can reduce, you reduce, which here you can reduce to 1/2. So there's a 50% chance, a 1/2 probability that you would pick a number that is not a multiple of 3 or 5. Y'all feel okay about this? All right, let's move on to the next one. Okay, this Venn diagram's already filled out for us. It says Miss Snow conducted a survey in her homeroom. She asked students what math course and what science course they were taking this semester. Below are the results. So the students in Miss Snow's room all are listed here. So you can see 14 of them are taking out, I think this is supposed to be algebra 2 because all these say algebra 2. So I'm going to put the 2 here. So 14 students are taking algebra 2, but not chemistry. 5 are taking chemistry, but not algebra 2. And then you can see 4 in the middle. 4 students are taking both algebra 2 and chemistry. And then these 6 that are on the outside of the circles, but in the rectangle, those represent the students who are not taking either of those classes. So how many total students this is, it should add up to how many students are in her class. So that is 29. So there's 29 people in her homeroom class. She got 29 students in there. Says how many people are taking both algebra 2 and chemistry. That's the overlap in the middle. So there's 4 in the overlap. What is the probability of selecting someone from the class that is taking algebra 2 but not chemistry? Well, that's the left side. Algebra 2 but not chemistry is this subset, which is 14. Out of the total 29. So you've got a 14 and 29 chance of picking someone who's in algebra 2 but not chemistry. Now this is the notation I was just showing y'all. That slash up here I showed you, when that means given that second criteria. So the probability of A given B. So this is asking the probability of picking someone in algebra 2 given that they're in chemistry. Write that word given if it helps you. Okay, so given that they're in chemistry means I'm only picking students who are in chemistry out of students who are in chemistry. So the total number of students in chemistry over here, there's the 4 that are in both, the 5 that are just in chem. So that's out of 9 students that I'm picking. Okay, so there's 9 to pick from. And the ones that are in algebra 2 is that overlap of 4. So there are 4 out of, there is a 4 out of 9 probability that I would pick someone in algebra 2, given that they are also in chemistry, given that I'm picking that they're in chemistry. All right, number 5, once the probability the student is not taking Algebra 2 or chemistry. Well, that was the people on the outside here. So they're not taking either. There were 6 of them out of the 29 in the class. So a 6 in 29 probability. So far, so good? All right, on number 3 diagram. This one's a little more confusing. It just takes a little more thought because they don't give us the numbers just to directly plug in. We have to do some subtracting to figure out what goes where. So the information that's given is that students survey 758 spectators at a national championship tennis match. So 758 is our total. Go ahead and write that here outside the box. So there's 758 people surveyed. That's our universal set. Okay, all the numbers that I write in here should add up to 758. The survey results indicate the following: 421 males, 256 have a two-handed backswing, and 176 of the people with a two-handed backswing are female. What's the probability the person is male? What's the probability the person has a two-handed backswing? So our 2 subcategories that we're being asked about are male and a two-handed backswing. So that's what I'm going to label my 2 subcategories, my 2 ovals here. Okay, so male and a two-handed backswing. So I know the total males is 421, but there's 2 sections here that need to add to give me that 421. The total two-handed backswing should be 256, but again, these 2 sections need to add to 256. Now it says 176 of the two-handed backswing are female. So that means 176 have a two-handed backswing and are not male. So that 176 is going to go here. It came from that sentence. So they're not male. Now, 256 have a two-handed backswing. So I'm going to subtract the 176 females and see how many are left, because the remainder must be males with a backswing. So 256 minus 176 leaves us with 80. 80 other people have a two-handed backswing and are not female, so that must be 80 here for the overlap. So 80 of these spectators are male and have a two-handed backswing. Now they told us the grand total of males was 421. Now I know 80 of them are in the overlap, so what's left is 341. So that's going to go here. Now the grand total is supposed to be 758 spectators. If I add what I've used up here, 341, 80, and 176 is 597. So if I take the grand total of 758 spectators and I subtract who falls into these subsets, that leaves me with 161. So that means 161 are outside of those ovals. So this would be the females that don't have a two-handed backswing. Because they're not male and they don't have a two-handed backswing. What's the probability the person is male? Well, we know the grand total of males. They told us here, 421 out of the grand total surveyed was 758. If you can reduce your fraction, reduce your fraction. This one does not reduce. If you're asked to give it as a decimal, you can, or convert it to a percentage. This is approximately 0.555, which I would say is about 55.5%. So over half, around 55.5% of the people there are male. What's the probability that the person has a two-handed backswing? So again, a two-handed backswing was up here, 256. Out of the grand total of 758. Now, if your fraction reduces, we want to reduce it, or give it as a decimal if you want to, or a percent. This fraction does reduce to 128 out of 379. Okay, or as a percent, that's approximately 0.3377. So I would say about 33.8%. So about a third of the spectators have a two-handed backswing. You feel okay about that one? All right, in number 4, Mr. Salinas' geography class has 31 students. So that's my total. I'm going to put that down here outside the box. It says 13 have brown hair, 12 have blue eyes, 8 have both brown hair and blue eyes. So blue eyes and brown hair are my two subsets. And I know the total of each, and I know the overlap. So I'm going to start with the overlap. 8 have both. So 8 goes in the middle. Then I'm going to figure out those differences. So for blue eyes, it says 12 total. So if I take out those 8, that leaves me with 4. So 4 students have blue eyes, but not brown hair. I'm going to do the same thing to figure out. There's 13 that have brown hair. I take out those 8, and that leaves me with 5. What's going on with my pen? There we go. So far, so good? Now, if it's a total of 31 students and I add these 3 subcategories and the overlap up, that is only 17. So I need to calculate how many students are left if there's 31 in the class. So that comes out to 14. Okay, so I just did 31 minus all of those that I've already categorized. What is the probability of selecting someone with blonde hair? We don't know. We know 13 have brown, but of all the remaining students that don't have brown hair, there's 18 of them. We don't know who has blonde or who has black or who has red hair. So we cannot answer that question with the information we're given. So I'm just going to say not enough information. Can't answer that one. How many people have blue eyes but not brown hair? So blue eyes but not brown hair is the 4 out of a grand total. Well, it didn't ask for the probability, so just 4 is your answer. If they asked for the probability of picking someone with blue eyes but not brown hair, you would say 4 out of 31. But they didn't ask for the probability. Your answer is just 4. All right, last but not least, we're going to create a slightly more complex Venn diagram. Okay, this one talks about a guidance counselor planning schedules for 30 students wanting to take a foreign language. Here are the preferences. 15 want to take French, 16 want to take Spanish, 15 want to take Latin. Now there's some overlap in those. It says 7 want to take both French and Latin. 4 of the people who want to take French and Latin also want to take Spanish. 6 want to take only Latin, and 7 want to take only Spanish. So I'm going to draw my diagram and start filling in backward from the sections that I know for sure. And then we'll have to find some differences to fill in the missing pieces. So it's 3 languages that are the choices: French, Spanish, and Latin. So I'm going to have 3 circles this time instead of 2. So if you have a 3 subcategory Venn diagram, it's going to look something like this. You're going to have the 2 overlap like normal, and then a third can be drawn at the bottom overlapping both of them. So you end up, you have 3 circles. The top 2 have an overlap section. The top left and bottom have an overlap. The top right and bottom have an overlap. And in the center, there's an overlap of all 3. Y'all feel okay about that? So I'm going to label those. So we are going to have, it says French, Spanish, and Latin. So I'll do French in red. Spanish bold. Latin in blue. All right. I'm going to start with what I know for certain of these, because there are 1, 2, 3, 4, 5, 6, 7 different sections within these circles. Okay, so there's the overlap of all 3, the double overlaps, and then the solos. It says 7 want to take only Spanish. So that part right there, only Spanish. That's going to be out here. There's 7. 6 want to only take Latin. So Latin only, there's 6. 4 of the people who want to take French and Latin, so the overlap of French and Latin is down here, okay? This section here is French and Latin. It says 4 people want to also take Spanish. So it's this little section right here in the middle that is the overlap of French, Latin, and Spanish. So all 3 overlap here, and it says there's 4 of those students. So 4 people want to take Spanish, Latin, and French. Then it says 7 want to take French and Latin. Well, if you look at the overlap here, French and Latin, that's right here. Y'all see that? That's the overlap. We've already got 4 people in that. So if it says 7 of people want to take both and 4 of them are already listed here also wanting to take Spanish, how many are left for this section that only want French and Spanish? Or sorry, French and Latin. This total is supposed to be 7, and I've already written down 4 of them. There's 3 left, aren't there? So that's going to be 3. Okay, now 15 want to take Latin. Let's look at what I've got in Latin so far. I've got 6, 3, and 4 that fall into this Latin circle. 6, 3, and 4 fall into the Latin circle. So that's 13, and it says there's 15. So if the total needs to be 15, and I've used 13, that means there's 2 left that will want to take Latin and Spanish. So this overlap between Latin and Spanish. So now in the Latin circle, there are 15. 16 want to take Spanish. Well, in the Spanish circle so far, I've got 7, 8, 9, 10, 11, 12, 13. So this is 13 people so far, but 16 want to take Spanish. So that means there must be what did I say that added up to? 11, 13. No. Yeah, 13 again. So that is 3 left that must want to take Spanish and French. So that's a total of 16 in the Spanish circle, which is what it says. So far, so good. And then 15 want to take French. Well, in the French circle so far, we only have the overlapping ones, but that's 3, 6, that's 10 so far. So if there are 15 who want to take French, what just happened? There are, come on. I don't know what's going on with this. It's being super laggy and not working. I'll try this again. Let me get all my PDFs closed, then maybe this will work. Here we go. Okay, so as I was saying, 15 want to take French, and we've used 10 in here. That leaves 5. Must want to take French only. Now, there's a total of 30 students, and if I add all of these together, that hits all 30. So there's nobody left to go in the outside of the circles in the rectangle. All 30 are accounted for within these circles. So it says, how many people want to take only French? That's the one I just filled out, 5. What's the probability of picking a student who wants to take French and Spanish? So French and Spanish has 2 overlaps here. The ones that also want to take Latin and the ones that only want to take French and Spanish. So we have to put those together. So that's 7 that want to take French and Spanish out of 30 students. So a 7 in 30 probability of picking one who wants to take French and Spanish. And then the probability of choosing someone who wants to take a foreign language. Well, I already said all 30 were accounted for in here. So there's none that don't want to take a foreign language that she's working with in this data. So it's 30 out of 30. It's 100%. A 1 probability is 100% if you change it to a percent. Now this one is probability of French and Latin and Spanish. So this is the probability of a student wanting to take all 3. So that is that middle section here. So there's a 4 in 30 chance that that's who you would select. And that does reduce to 2/15. So when you can reduce your fraction, you reduce. The 30 over 30 reduced to 1. 70 over 30 does not reduce, so that one you can leave. All right, so this is probability with Venn diagrams and creating Venn diagrams. So now y'all are going to try this. This practice is not on Delta Math. Delta Math did not have Venn diagram practice, so this is on paper. So you do have a worksheet. What you don't finish in class today, you will just bring back with you tomorrow, and you'll keep working on it tomorrow. Tomorrow is a work day for any incomplete Unit 11 assignment.